If you're preparing for a .NET interview, you've probably seen those massive lists of 50 common questions. It's tempting to try and memorize every answer using flashcards, but that usually backfires the moment a recruiter asks you to explain the why behind the code. ASP.NET Core is a highly predictable system. It operates just like an automated factory assembly line, where requests move through specific stations. Once you understand how these stations work together, the answers to those 50 technical questions become obvious. You stop reciting definitions and start describing the system as it actually functions. The legacy .NET framework was built specifically for Windows. Modern .NET Core functions like an off-road vehicle. You can build your app on a Mac and host it on Linux without changing the engine. That engine is called Kestrel. It's a lightweight, built-in web server that comes standard with the framework, allowing your application to listen for and handle web traffic on almost any operating system. Interviewers often check your knowledge here by asking about .NET Standard. Think of the standard as a formal blueprint or a set of rules, while .NET Core is the actual machine built to follow those rules. This portability is the main reason modern companies have moved away from the older, Windows-only versions of the framework. To understand how the assembly line processes data, imagine an incoming web request is a passenger arriving at an international airport terminal. Before they can board a flight, they must pass through Middleware. These are the mandatory security checkpoints, like baggage scans and ID verification, that every request must survive. Middleware handles the cross-cutting tasks, like logging the request or checking for errors. Once the request clears security, it looks at the departure board to find its gate. In our system, this is routing. It reads the URL the user typed in and directs the request to the specific gate or controller that knows how to handle it. The sequence of these checkpoints is critical. If you put the authorization check before the identity check, the whole system breaks. The order you define in your code determines exactly how requests are accepted or rejected. Once a request reaches its destination, the code needs tools to do its work. Dependency injection is like a smart restaurant supply chain. Instead of making a chef build their own stove, the system simply delivers a working stove to the kitchen when it's time to cook. You'll be asked about service lifetimes, which determine how often the system delivers a new tool. The first is Transient. This is like a disposable paper cup. The system hands out a brand new one every single time a service is requested. Next is Scoped. This is like brewing a single pot of coffee for one table. Everyone at that table shares the same pot, just like every part of a single web request shares the same instance of a service. Finally, there's the Singleton. This is the large industrial coffee machine in the lobby. There is only one for the entire building, and it stays there for as long as the restaurant is open. This supply chain keeps your code loosely coupled. It makes the application easier to test and prevents memory issues by letting the framework handle the cleanup. Security is often the hardest part of the interview, but it's simpler if you separate the two main steps. Authentication is the bouncer checking your ID to see who you are. Authorization is checking for a VIP wristband to see what you're allowed to do. You establish these identity rules at the very beginning of a project using these configuration settings. Modern apps use JSON Web Tokens, or JWTs, to handle security without a constant database connection. First, the app sends a password to the authentication service and receives an encrypted token. It then presents that token to the API to access restricted resources. This token-based approach allows your API to handle thousands of users across multiple servers simultaneously, because the servers don't have to store or track every individual's active session. To talk to a database, we use Entity Framework Core. It's a translator that converts your C# code into raw SQL that databases understand. You'll likely be asked about loading data. Lazy loading translates individual pieces of information only at the exact moment they're needed. Eager loading translates and pulls everything in one big batch right at the start. You can also choose how to build your structure. Code first means you write the C# rules and the framework builds the database for you. Database first means the framework looks at an existing database and generates the code to match it. This separates your application logic from the database engine, allowing you to focus on your C# code while the framework handles data communication. If we look at the whole journey, the request, the middleware, dependency injection, and the database, we can see the entire map of the framework. Most interview questions are just specific inquiries about what's happening at one of these 4 stops on the line. When you understand the architecture, the answers follow naturally. Save this video to review before your next technical round, and subscribe for more deep dives into the .NET ecosystem.